video, we're going to talk about how to solve trig equations. So this is what this whole semester has been leading up to, is how to solve trig equations. So one thing that we know about trig functions is that they're periodic. That means that they repeat themselves over and over, and because of that, trig functions have infinitely many solutions. So let me write. Trig functions are periodic. So trig equations have infinitely many solutions. So what that means is not that every single thing is an answer, it's just that the same answer repeats itself over and over and over again. So for example, the function y equals sine x. We know if we graph that function, if we graph one period of it, one period is going to look like this, but it still repeats itself over and over. So I could keep on drawing this, so on and so forth, like that. And I could also go this way. Not the best rendering, but you get the idea. Okay, so that's the graph of y equals sine x. So if I was trying to figure out where does sine x equal to 0.5? Well, on this graph, I know this top part is 1. This bottom part is at -1. So positive 0.5, 1/2 would be about right here. That would be the line y equals 1/2. Okay, so I have lots of places where this is the answer. Right there, right there, right there, right there, here, 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 so on and so forth. So that's one way you could think about them having infinitely many solutions. Another way you could think about it is on your unit circle. Where is sine x equal 1/2? Well, right here it equals 1/2, but also right here. So it's pi over 6 and 5 pi over 6. But then I can go around another time, and like this would be, let me do it real fast. This would be 13 pi over 6. And I could keep on going around and around and around and getting more and more answers there. I could also go backwards to get answers that way. Okay, so there are infinitely many solutions. So when we solve our trig functions, you kind of have to read the directions. Sometimes the directions will tell you to find your solutions in one period. Sometimes they'll tell you to find your solutions in 2 periods. Sometimes they'll tell you to give all solutions. So that's kind of what we're going to practice today, is how to solve and give all solutions, or whatever type of solutions they're asking for. Okay, so let's remind ourselves about the periods for our trig functions. So remember that sine, cosine, cosecant, and secant all have a period of 2 pi. And then tangent and cotangent have a period of 1 pi. Okay, so when we're using our periods to, or our knowledge of periods to write the number of solutions, or what our solutions are for our trig functions, you just have to remember that all of these have a period of 2 pi, and tangent and cotangent have a period of just pi. Okay, so let's solve this problem that we just did. Okay, so our first example, we're going to solve the problem sine of theta equals 1/2. So to solve that problem, the first thing we do, so I'm going to say part A, is we find our solutions for one period. And once we find our solutions in one period, oh, you can't see that very well. I won't use a pencil anymore. Once we find our solutions in one period, then we can use that to find all the solutions. Okay, sorry. So once you find the solutions in one period, you can then find the solutions in all the periods. So to find the solutions in one period here, since it's 1/2, I can use my unit circle reference angles. So sine, again, is the y value. Where's the y value equal 1/2? Well, it equals 1/2 at pi over 6 and at 5 pi over 6. So that's the y value of positive 1/2. So I know that theta is pi over 6 and 5 pi over 6. So that's nothing new. We've been solving technically simple equations like this, essentially using the inverse or using our unit circle. The new part is, what are all the solutions? So once we find the solutions in one period, then find all the solutions. And we find all the solutions by using the answers we just found. So by using one period. So I know that every time I go around this unit circle, at this angle right here, I'm going to have an answer, and at this angle right here, I'm going to have an answer. So all the solutions here would be pi over 6 plus 2 pi plus 4 pi plus 6 pi plus 8 pi. So the way we would write that is theta equals pi over 6 plus 2k pi. And you can write, this whole k is the idea of an integer. So it's positive 1, positive 2, positive 3, 0. Or we can also go backwards. Negative 2 pi, negative 4 pi, negative 6 pi. Okay, so negative numbers. So k is an integer. So you can write k equals an integer. You can also see it written as k is a part of the set of integers. You could list it out. K equals like negative 2, negative 1, 0, 1, 2, 3, so on and so forth. And like you just have to show that it goes both ways. So however you want to do it, that's the solution for this part right here. For this answer over here, it's 5 pi over 6. So theta equals 5 pi over 6, the same thing, plus 2k pi. And that gets you all of your answers. So this right here is your answer, and you only have to pick one way to write it. You don't have to write it both ways. Okay, let's do another one like this. So if you're asked to solve cosine of theta equals negative square root of 2 over 2, and we want to list 8 specific solutions. It doesn't tell you which 8. You can pick any 8 that you want to, but you need to give 8 different answers here. So first thing let's do, let's find the answers in one period, find the solutions in one period. So think about your unit circle. Cosine is an x value. Where is an x value? Negative square root of 2 over 2. Well, right here and down here. So at 3 pi over 4 and at 5 pi over 4. So theta is 3 pi over 4 and 5 pi over 4. The way we would find all the solutions is, remember, sorry, I think I did this A and B a minute ago. The way we find all the solutions is to add 2k pi to both of these. So all the solutions technically is 3 pi over 4 plus 2k pi, 5 pi over 4 plus 2k pi. So if I want to find 8 specific solutions, I'm going to plug in 2 numbers for k here. Because if I plug in one number for k, I get 2 here. Plug in another number, I get 2 more. Okay, so pick some numbers for k. You can pick any number here, again, because it only asks for 8 solutions. You could technically pick 100, 101, 102, and 103. I'm just going to keep it simple. So I'm going to do negative 1, 0, 1, and 2. So those 4 numbers will give me 8 solutions here, because when I plug in negative 1 here, negative 1 here, I get 2 answers. Okay, so for k equals negative 1, when I plug it in, theta equals 3 pi over 4 plus 2 times negative 1 is negative 2 pi. Okay, and when I add that together, this is like 3 pi over 4 plus negative 8 pi over 4 if I got a common denominator, which would be negative 5 pi over 4. And that's one answer. Okay, if I plug in k equals negative 1 here, 5 pi over 4 plus negative 2 pi. Same thing as 5 pi over 4 plus negative 8 pi over 4, which gives me negative 3 pi over 4. So that's a solution also. So there's two solutions when k equals -1. Now let's plug in k equals 0. This is the easiest one to do. So we have 3 pi over 4 plus 2 times 0 is 0. So it's just 3 pi over 4. Same thing for 5 pi over 4. 5 pi over 4 plus 0 pi just gives me 5 pi over 4. So I have 1, 2, 3, 4 solutions now. Let me get 4 more. For k equals 1, 3 pi over 4 plus 2 times 1, 2 pi is the same thing as 3 pi over 4 plus 8 pi over 4, which would be 11 pi over 4. Same thing over here, 5 pi over 4 plus 2 pi is the same thing as 5 pi over 4 plus 8 pi over 4, which would be 13 pi over 4. Okay, so there's 6 solutions. Now let me plug in k equals 2. So for k equals 2, 3 pi over 4 plus 2 times 2 pi would be 4 pi. So common denominator would be 3 pi over 4 plus 4 times 4 is 16 pi over 4. And that would give me 19 pi over 4. Okay, and then over here, 5 pi over 4 plus 4 pi is the same thing as 5 pi over 4 plus 16 pi over 4, which gives me 21 pi over 4. Sorry. Okay, so there's 8 solutions right there. -5 pi over 4, -3 pi over 4, 3 pi over 4, 5 pi over 4, 11 pi over 4, 13 pi over 4, 19 pi over 4, 21 pi over 4. Again, you don't have to do these exact 8. To me, these are the simplest ones to do because it's the smallest numbers. Again, if you're plugging in like 100 here, you'd have to do a little bit more math. So I would encourage you to do the smallest numbers possible, but it's totally up to you. Again, also, if you wanted to skip, like, if you just wanted to write -2 pi as -8 pi over 4, like skip this part and just write this part, that's fine also. Okay, but there is 8 solutions there. If the question asks for all solutions, this is the answer for all of the solutions, and here's 8 specific solutions. Okay, so that's doing to show 2 problems using the unit circle to get your answer. Let's do one that's not on the unit circle. So for example, if I had the problem, solve cosine of theta equals 0.65. Okay, so I don't have this on my unit circle. I don't have anywhere that 0.65 is an ordered pair. Okay, I can kind of think about it though. 0.65 is going to be bigger than 1/2. So essentially, what I'm doing is looking to figure out where my x value is a little bit bigger than 1/2. We'll come back to the unit circle in a minute. Okay, so the way I would solve here for theta is I would do the inverse cosine. Oh, and I forgot my calculator. Darn. So I would do the inverse cosine. So remember, this is like where theta equals cosine inverse of 0.65. When you put this in your calculator, again, I forgot to bring mine up. Sorry for that. If you have a question about how to put that in your calculator, definitely email me about that. But when you put that in your calculator, you get that theta equals, where's it at? A decimal, and if you round it off, you get 0.86. Okay, so that's only one of my answers, and I know that I should have 2 answers here. So the idea to figure out where the other answer is at, if I kind of think about my unit circle, 0.65 is like a little bit more than 1/2. So where is an x value a little bit more than 1/2 on the unit circle? Well, x value a little bit more than 1/2 on the unit circle would be right here. Or that's half, so a little bit high. Oh, that's a y value. A little bit more. So like here's your x values right here, your x-axis. So like right here is where you go over 1/2. So a little bit more would be like here-ish. Just guessing, right? So about this point right here, which is this. So the x value is 0.65. The y value is 0.86. Okay. Where else on my unit circle do I have a positive x value? Well, not in this quadrant. X is negative in both of these quadrants. It's down here. So it'd be down here also. Okay, so this would be positive 0.65. This number is this height, positive 0.86. So down here, to figure out what the number would be here, I would do two pi minus the 0.86 to figure out what this number is. Because if I subtract it, like you could write it like technically negative 0.86, but we're trying to figure out the amount you're going around essentially. I wrote this wrong. Okay, sorry, that's not the y value, that's the angle here. I'm sorry. So the angle here actually is 0.86. I don't know what the y value is. You could figure it out technically if you did sine of that. Okay, so this angle is 0.86, which is kind of weird because we're used to our angles to being like a pi over something. So to figure out this angle down here, to figure out what this angle is, technically you could say it's negative 0.86. But again, these angles were going around positive. So the way you figure out the positive angle here is 2 pi minus that will tell us what it is. Okay, so when you're using not using your unit circle to get the exact values, we're going to do 2 pi minus this number, minus 0.86. And when you type that in your calculator, you get, it's 5.42. So that number I just found, 5.42, that's how to write this angle like this all the way around like this. Okay. So those are my two solutions. So two solutions in one period. Okay, so if the question just asked to give two solutions, there's two specific solutions. If we wanted to give all the solutions here, since this is cosine, I'm just going to do these two answers plus 2k pi. So my answers are 0.86 plus 2k pi and 5.42 plus 2k pi. And remember to write what k is. K is an integer. You can write like that, either one. So that's my answer for all solutions there. Okay, so that was solving sine, cosine, using the unit circle or doing it using the inverse function, okay, on your calculator. Let's do one with tangent now. So if I was trying to solve tangent of theta equals 2. The biggest difference with this, you're still solving it essentially the same way. The only difference is when you go to write your period, remember that tangent has a period of 1 pi. So it's going to change our answer a little bit. So, same idea, tangent equals 2. So this is where sine over cosine equals 2. This isn't really one that you can use your unit circle on because I don't have anywhere on my ordered pairs where my y divided by x equals 2. So this is another one I would use my calculator for. So to use your calculator, you're taking the inverse tangent. So inverse tangent of the number 2. And when you type it in your calculator, you get 1.1. Okay, so remember, since tangent only has a period of just pi, that means that you're only going to get one solution here. Okay, so you don't have to subtract from 2 pi here because you're only going to get one solution. So that's my answer for one period. To find all the solutions here, it's going to be theta equals 1.1 plus k times pi. Instead of 2k pi, it's just k times pi. And again, k is an integer. Okay. So that's how to do tangent. Same idea. The biggest difference is when you write your answer, it's just k pi instead of 2k pi. Okay, we're going to do a few more problems just to show our equations start to get a little bit more difficult. So I'm just going to do, like, if you'll notice, all of these equations essentially were like just basically like x equals a number or y equals a number. Like all we had to do was do the inverse function. So now let's kind of look at what happens whenever you have to do a little bit more work to get your answer. So for example, if I had the problem 2 times sine of theta minus 1 equals 0. Okay, so notice this is 2 times something minus 1 equals 0. This is similar to the equation like 2x minus 1 equals 0. To solve for x, the first thing you would do is add 1, and then you would divide by 2. And so you get x equals 1/2. Same thing here. First thing you want to do is add 1, and you get 2 sine theta equals 1, and then divide by 2, and you get sine of theta equals 1/2. And then solving for all the solutions here is the same way we did it before. Figure out for one period what your answers are, and then add 2k pi to it. So we actually already did this problem, sine of 1/2. That was the first problem we did. So the answer was pi over 6 and 5 pi over 6, and you add 2k pi to it. So theta equals pi over 6 plus 2k pi and 5 pi over 6 plus 2k pi, and k is an integer. Okay, look at this one. If I had tangent squared theta minus 3 equals 0. So tangent squared theta minus 3 equals 0. This is similar to the equation like x squared minus 3 equals 0. The easiest way to solve that equation is to add 3 to both sides and get x squared equals 3, and then take the square root. And remember, if you take the square root in a problem, you have to do plus or minus the square root of 3. Same thing over here. Add 3 to both sides, and then we get tangent squared theta equals 3. Square root both sides, and so I get tangent theta equals plus or minus the square root of 3. Okay, so here to solve, I need to figure out where on my unit circle is sine divided by cosine equal to square root of 3. So the places where sine divided by cosine equals the square root of 3 is, let's see, here, pi over 3, I get positive square root of 3, and then, so it's actually, there's an answer in all quadrants, but remember, like using inverses, tangent, the domain for tangent is only these two quadrants, is only quadrant 1 and quadrant 4. So I only want my answers in quadrant 1 and quadrant 4. So it's going to be pi over 3 and 5 pi over 3. I don't want these two answers because remember the domain of the inverse tangent function is negative pi over 2 to positive pi over 2. So just these two quadrants. So pi over 3 and 5 pi over 3 are my answers here. So pi over 3 and 5 pi over 3 plus, for tangent, it's not 2k pi, it's just k pi. And k is an integer. And that's my answer. Okay, so notice, same idea as before, it's just I'm adding a little bit of algebra to it. Let's go ahead and do one where it's a little bit more algebra, a little bit more of college algebra now. If I had the problem 2 cosine squared theta minus 7 cosine theta plus 3 equals 0. Okay, so notice I have cosine squared, cosine, and just a constant. This is similar to the equation 2x squared minus 7x plus 3 equals 0. Think about how you would solve that. You could solve using the quadratic formula. Think how awful that would be. Try to solve that using the quadratic formula. I'd encourage you not to do that. What other ways? We could also factor this. So you can factor however you want to. You can guess and check, and you can use AC method. It doesn't really matter. You just need to be able to factor that. So when I go to factor that, that factors into 2x and x. Let's see. The 3 needs to be here. The 1 needs to be here. And they're both going to be negative. So 2x minus 1, x minus 3. Okay, so that means similar, and the way I solve this is I set both of these equal to 0. 2x minus 1 equals 0. X minus 3 equals 0. So similarly over here, this factors into 2 cosine theta minus 1 times cosine theta minus 3. Oops. Okay, so instead of x, I'm just using cosine theta, and then set each factor equal to 0. So 2 cosine theta minus 1 equals 0. Cosine theta minus 3 equals 0. Add 1 to both sides. Divide by 2. And so I get cosine theta equals 1/2. Let me solve that. Where does cosine theta equal 1/2 at? Well, on your unit circle, where is your x value 1/2? Here and here. So pi over 3, 5 pi over 3. So theta is going to be pi over 3 plus 2k pi, because it's cosine, so I do 2k pi. And it's going to be 5 pi over 3 plus 2k pi. Again, k is an integer. Over here, add 3 to both sides, and I get cosine theta equals 3. That's not on my unit circle. When I go to take the inverse on my calculator, again, I don't have my calculator, sorry. If you type this in on your calculator, it'll say undefined. Because remember, the range of cosine is -1 to +1. The highest it goes is +1. The lowest it goes, cosine is x values. -1 to +1. Also, if you think about your graph, it can't go above the -1, +1. And inverse cosine, the domain is -1 to +1. So you don't get any answers out of this side. You only get answers out of this side. That's not always the case. Sometimes you get answers out of both. In this case, you only got it out of one of them. Okay? So that's my answers. They're infinitely many solutions. They're all the pi over 3s and 5 pi over 3s whenever I go around my circle multiple times. Okay, let's go and do one more of those. No, actually we're gonna stop here. I'm gonna make another video with a little bit more complicated equations. So this is the pretty straightforward ones, just using some algebra to get your answers. Make sure you understand this before you move on to the next video.